Good morning, YouTube friends. So my last couple videos, I got up to the alignment and test part 2. I was doing the 4 megahertz oscillator calibration, which the numbers were fine on frequency. And then we did the PLL reference oscillator range, that was fine on frequency. But then we did the voltage controlled oscillator test, and that's the voltage driving your VCO. The voltage on that is low, and I didn't put it all on camera, but I did much of it. L30 and T5 are the two components that you're looking at. We moved L30 to its lowest range, did not get up to 6 volts. I overturned it. I think I damaged it. I removed it. This is a new one. And I didn't do a video of all this stuff because it's just time consuming and monotonous. And if you're building one of these, you know what I'm talking about. I put the new one in. My voltage range was working, but still too low. I started at like 2.5 volts with this thing all the way out. I put it all the way in. I got 4.5 volts. I'm supposed to have 6. I contacted the Elecraft reflector. Got an answer from Don Wilhelm, who is the main tech guy on Elecraft that does troubleshooting and repairs for Elecraft, works for Elecraft on the K2s, and he answers very quickly. He's a great guy and extremely knowledgeable about these radios. He built one of the first ones and knows them inside and out. Anyhow, he suggested a couple things. There's the Q19 FET, which is, I don't know if I can see it on camera. Yeah, it's up here where the tip of that green thing is. I took the source for that FET to ground, and I guess it was a bad batch of these Q19s. I bought this radio almost 2 years ago now, so I don't know if I had a bad one. It's possible. But anyway, he wanted me to put a 10 to 15 puff capacitor to ground from source on that. I did that. I had a 15 puff on hand, and it knocked it out completely. My voltage dropped to nothing. I had 0.02, which is essentially 0 on my meter, with that to ground. And I tried 2 different capacitors. I had a ceramic and I had a mica, and they both did the same thing. I just wanted to compare them. So I verified that part, that that didn't fix it. He said that may fix it, and it did nothing. It knocked out the voltage. So a couple more people answered me, and this is my question, and I actually presented this to Don as well, although he didn't get back to me yet. He said I may have to change that transistor. Another fella said to change the turns on T5. He added a turn, and I was thinking about doing that anyway. There's 16 turns of the red wire on the one side of the transformer and 4 turns of the green wire on the other side of the transformer. Step down, step up transformer. And he put 17, and he got the right voltage range. So that is my next move. I'm going to do that off camera. I'm going to I have the plastic. There's a plastic cap that goes over this. I took that off. Oh, and by the way, the other thing I did is part of my troubleshooting. I did take this out, and I made sure the green wires were halfway between the red wires. So I have like 5 spaces over here and 6 over here. It's an uneven number, and because I had them a little off. That made no difference. So, but I'm going to take this out. I'm going to get a new piece of red wire. I'm going to put 17 wires on here, and I'll be back with my test to see if that makes any difference. So I'll see you in a bit. Okay, we are back with the T5 transformer reinstalled. I have 17 turns on red. I have still 4 turns on green. I have the voltmeter on place on R30. We are looking for a voltage of 6 volts. I didn't record it, but as I mentioned, I have the slug in all the way, and currently my voltage is 4.5 average, a little less, a little more. Bounces up and down a hair. I'm going to power the radio up, and we'll see where we're at. Yeah, that's good. Okay, I have to have this at exactly 4,000 kilohertz. And you can see we're at 8.29 volts, so that is significantly higher, and I'm thinking I should be able to back it off and hit 6. I'm hoping. So we have to find L30, my inductor, which is in all the way. And we're going to start backing it off. And hopefully see our voltage drop. The voltage is not changing. This is not good. It's not budging. There we go, finally. That was... Hallelujah! Awesome. All right. And this is also being discussed on the Elecraft reflector. I've gotten a couple of responses from people, so if you're building one of these, you're probably a member of the Elecraft reflector and see the discussion, at least some of it. Some message were sent to me personally. I'm trying to post my responses back to the reflector. I always find on those things that, like, I always learn from reading other people's problems, you know. 6 volts. So what I'm going to do, I'm going to get this to 6, and then we're going to go back and do our frequency checks, and I'll do those on video, because that is really the most important thing, because this voltage drives the frequency of the VCO. I think we're good. That's pretty stable now. 6 volts at 4,000 kilohertz. Perfect. That did it. So I have 17 windings on the red winding of the T5 transformer, which is one additional to what the manual says. I'll be back. We're going to do my frequency checks. All right, I'm back with the setup with the frequency counter. This is the we're backing up a step to the 4 megahertz oscillator calibration and the PLL reference oscillator range test. So we previously had a initial frequency of 12099.37. So we're going to power this up, put on the counter, and see where we are at initially for our first reading. So we go to the menu, we change this to the frequency counter, which is Cal, and then we gotta hit that. Whoops, shoot. No, hold it. We turn this to Cal frequency. Yeah, that's right. Cal factor, FCTR. Hold it. Now the frequency counter is on. I'm not on the test point yet. So back here I have my frequency counter as my external source, clipped to the internal frequency counter on the radio. I'm going to ground this probe, and then we're going to put the tip of that on our test point and see where we are at. All right, we're pretty good. I don't think it's really changed. It's slightly different, but not much. I'm going to write down these numbers. So the radio is reading 12.09942. We're going to call that. It's going between a 1 and a 2. My counter is 3.9. You're supposed to match them, and I'm going to do that. And I did this before on camera, and it ended up being... I know you didn't see it, but here we are. We're flashing between a 39 and a 40 on both the external source and the internal source. So our frequency is good. Okay, and I'm going to keep the camera rolling because we want to... we then hit the band number, and we're looking for a reference range. Okay, so we're going to hit that. So, yeah, we're good. Our new reference range is 12085.7. We're going to call it 0, even though it's going between a 1 and a 0. So I'm doing this off camera, but I know you can hear me. I'm bringing up my calculator, and we want to see what our range is. Point 39 minus 12085.7. We have a range of 13.69, which is perfect. It has to be between 9 and 15, I think. Where is it? Yeah, between 9.8 and 15 kilohertz, and I have 13.69. It's almost exactly the same as before. My range before was 13.7, so it hasn't changed. So I have my frequency range. I have my 6 volts of voltage. I think everything is good now. The next test is the VCO alignment. No, I did that. I have to read ahead, and we're just going to be, I'm going to take more voltage checks. They have voltage check of 6 volts. You do a voltage check on every band, 80, 40, 30, 20, 17, 15, 12, and 10 meters. You write them all down. They're supposed to fall within a certain range, and if they do, your VCO is correctly working. I think it's working now. It looks good. We had the right voltage. So I'm going to do those tests off camera because they look very time consuming, and I'm not going to videotape all that. So I'll just say 73 at this point.